We wake up hungry every day. How we've satisfied that hunger over the course of time has changed because of agriculture.
From the dawn of history to about 10,000 BCE, humans are hunter-gatherers. Changed in different places at different times, but around the same time you observe a gradual transition towards a more sedentary kind of living that involves agriculture. One of the theories is that it may have had something to do with climate, or that there may have been changes in climate that affected the migrations, perhaps, of certain species that were important for hunter-gatherers. Climate changes possibly might have resulted in the development of more fertile regions where it became perhaps more immediately evident that you could grow things and continue to grow things productively.
So one of the theories, and my personal favorite for why agriculture got developed, is that people discovered beer. They realized that if grains were left in water, they fermented and formed this wonderful, rich, nutrient beverage. And they wanted more grain. And so they were really motivated to figure out how to produce larger numbers of grain, and that was one of the impetuses for developing agriculture, was producing more of these grains so that it was available to have to make more beer.
Fermented beverages notwithstanding, agriculture made it possible for people to settle in permanent communities. They didn't have to migrate all the time looking for food. Settlements sprung up along the fertile riverbanks. People learned to irrigate. They kept animals, and eventually larger cities emerged, as did abundance.
One of the things that you see associated with societies that are based on agriculture that are becoming, as I say, increasingly complex and stratified and developing obviously a great amount of wealth in comparison to what human beings had had before, you also see contention over that wealth. And so you see the development of warfare and technologies of warfare developing sort of alongside developments in agriculture.
Northern Europe was densely forested, so to make it ready for agriculture, you had to cut down all those trees. And for that, you use this very interesting compound machine called an axe. And an axe is made up of two simple machines. One is a lever, so you can see here very small motions on my hand, which is forming part of the fulcrum of the lever system, creates big changes and big swings at the bottom of the axe. The other part, the other simple machine involved in an axe is a wedge. And so this wedge here allows me to drive the sharp end into the tree and separate the tree, and allows me to fell that tree and get it out of the way so we can start to do agriculture.
There is a tool, a plow called the aratron, which is used prevalently in the Mediterranean region. It's a kind of scratch, it's called a scratch plow.
The soils in the Mediterranean basin were very light and very easily turned, so they were worked often with a scratch plow. That won't work in the heavier soils that we have in Northern Europe. You needed something much more sophisticated, so there was an entire evolution that happened in the tools for agriculture based on some of the soils and some of the needs of the local agriculture. So this is a plow that would be pulled by an ox or a horse, some sort of a draft animal. And it's similar to the sorts of plows that would be used in the Middle Ages. This edge cuts the soil, and then if I lift the plow up, you can see another edge perpendicular to that cuts underneath the soil. And then as the plow goes forward, the ground comes up this side and turns, and so it's flipped over as you go through in the plowing process. So this is a harrow. The draft animal would be attached up here to the front, and you can see these spikes that are lined up in the back here, and each of those would be dragged through the ground, and that would help level the ground out and prepare it for planting. And the planter is also an interesting machine. You can see a blade here in the front that's going to create a sharp furrow for the seeds to be dropped into. So this is going to push along, and then the seeds will come out into the furrow created by that blade. To help support the weight of the whole machine, you can see that there's a wheel on the back side, and again, a draft animal would be attached out to the front to help pull it through the soil. So all of these tools require a fair bit of force. I mean, think about forcing a plow through the soil. You have to cut it, you have to turn it. That takes a lot of effort to have happen. I mean, we've all probably used a shovel to turn over some soil, and This is trying to automate that. Initially it was mostly human-powered, but along with growing agriculture, there was also domesticated animals. And pretty quickly people figured out that they could harness an ox to the plow and have the ox drag the plow behind it. And that simplified the entire production. It greatly increased the productivity because the oxen was able to do a lot more of this work than a human being could do.
Medieval people began to see the advantages of using horses as plow animals. Once they were able to address some of the problems, and one of the things they were able to do was put shoes on horses. This is a medieval innovation. The Romans did not have horseshoes. And another thing that they were able to do to make the horse more effective was a harness that did not press against the horse's windpipe and jugular vein.
That was the first use of horsepower, though that term didn't come along until much later when Scottish engineer James Watt compared the output of a steam engine to the power of a horse. If the name Watt sounds familiar, it may be because the unit of power we all refer to today is named for him. But there's another word we use now that actually has its roots in medieval agriculture.
Furlong is actually a shortened version of furrow-long, and that unit of length, the furrow, is the amount of work and the distance an average horse would travel before it needed to take a break. And when the horse needed to take a break and rest a little bit, that was a great opportunity to turn the plow, which was a very difficult operation to do. So you would go as far as the horse could go in one direction, and that would be a furrow long or a furlong, and then turn the plow and go back. So that measurement of a furlong comes from the length the horse can go.
The tractor you see behind me is an example of a machine that is used in agriculture in order to produce the crop and to do it in an efficient and productive manner. We have now entered another phase in which we have computers that can help us make those machines more efficient so that they produce more crop with less costs and with less environmental impacts. And this is precision agriculture. So the advantage of precision agriculture is we only do what we need, where we need it, at the right time. This allows us to save money. There is no sense spraying pesticide, putting fertilizer, or tilling the soil where we don't need it.
The tractor behind us, if you notice the little white globe on top of the cab, that's the antenna or receiver that's collecting data from the satellites that are above us. There is a setting on the monitor that allows us to calibrate the terrain compensation module, and that calibration allows the satellites to guide the tractor in a line that will give us the proper pass-to-pass accuracy. If we didn't compensate for the terrain, the tractor would be moving in a spot that's going to be probably 3 feet down the hill from where it should be.
All the way up and down the row, it will guide itself. When you get to the end, I manually will make the turn. And I gotta raise up the disc to do it.
Basically, we're trying to do a better job of preparing the ground where we're going to plant the seed. And we're trying to get across the ground one time rather than multiple times to prepare the soil for planting.
Environmentally, one of the biggest things that it'll help with is erosion and compaction. When we have soil runoff, our topsoil layer is washed off the field, and it usually runs into our freshwater systems. This has caused a lot of eutrophication in stream beds. Eutrophication is when there's more nutrients in the water than there should be. So that means algae blooms can happen, growth of plant life. Sometimes you can see any issues within the aquatic life because of that. The other really big staple is the efficiency, because efficiency leads to fuel efficiency.
The tractor would consume approximately 7 to 10 gallons of diesel fuel per hour. And by using the GPS technology, we can maximize the coverage and have the limited amount of overlap, and therefore the cost of production will be less.
Sensors themselves are central to all parts of precision ag. There are sensors that are particular to the navigation of the tractor. There are sensors that monitor yields in crop as you're harvesting. There are sensors that go out and look at the crop as it's growing to try and determine what you should be doing to the crop, what kind of treatments you should put on them at what times. This is a kind of a ratty piece of corn at a V3 stage, so early in when it was planted. And at this stage, you can go out, and if you have the right sensor, you can take an image, a photograph of this, either from a satellite or from maybe a UAV, a drone flying overhead, or from something mounted on a tractor, and you can tell how healthy this is and maybe get an idea of what kind of nutrients you should put on this. So we want to look at the red reflection and the infrared reflection. And if we do some math on those two intensities, we can tell how much chlorophyll is in this leaf. And from that, we can get an idea of how much nitrogen is in the leaf. And if there's too much nitrogen, we don't want to put any on the field. If there's not enough, we might spray a little bit.
We can be able to monitor the things that are happening to those crops and be able to predict a insect infestation, predict maybe a lack of water, or predict some other problem. Amazing amount of data can be obtained when we fly like a drone over a field and can see what that drone's view is.
We have a big challenge these days. There are 7 billion people in the world. By 2050, there'll be 9 billion people. How do we feed all those people?
The total effect of precision agriculture is to increase yields and also to reduce environmental concerns.
None of this is magic. You know, it all takes work to get it to work. Lots of programming, lots of field trials.
I think it's important for people to understand that farming is changing and farming is different than it used to be. It's become a whole new level of complexity that people have to understand. Farmers are not uneducated people. They have to be actually at the top of their knowledge because they are the people who are producing the things we rely on.
Medieval people considered their society to consist of 3 orders. So those who pray, those who fight, and those who till the soil. And nobody doubted, even in the Middle Ages, the extreme importance of those who till the soil.
We have to all understand where things are coming from and how much work is being put into what we're getting. There's a lot of technology developing, there's a lot of engineering going on, because ag is one of the biggest markets in the United States.
From sensors that monitor soil and water to plows that know just how much dirt to move, there are many modern applications guiding agriculture today. The question is, can we balance those technologies with the renewed desire to return to traditional farming techniques and still meet the needs of feeding a growing global population?